Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to learn energy stored in the capacitor. You know that capacitor stores charges and energies. When a battery is connected to the capacitor, the electrons are transferred from one plate to another. Here the work is done by the battery. This work done is stored as electrostatic potential energy in the capacitor. To transfer an infinitesimal charge, say dq, from negative plate to positive plate, the amount of work dw must be done on the charge dq is dw is equal to V dq. This is my equation 1. What is this V? This V is nothing but potential difference. So dw is equal to V dq. How did I write this equation? We have already learned work done is equal to V into Q. Here I transferred an infinitesimal charge dq. So the work done on the charge is dw. That is why I have written dw is equal to V dq. This is equation 1. Initially the charge on the capacitor plate is Q is equal to 0. As the capacitor is being charged, the charge gradually builds up. After some time it reaches the value Q. Then how do you find out the total work done? The total work done needed to charge the capacitor is integral dw is equal to integral 0 to Q. Initially the charge on the capacitor plate is 0. After some times it reaches the value Q. So integral 0 to Q V dq. We know the formula, that is capacitance C is equal to Q by V. Suppose I want to find out V means, you can write it as Q by C. Substitute this in this equation. So 0 to Q, Q by C dq. Here C is constant, take it outside, 1 by C integral 0 to Q, Q dq. In the left hand side you have dw, integral dw. How do you solve this integral? By using one formula, integral of x to the power n dx is nothing but x power n plus 1 divided by n plus 1. Apply the same formula here. Instead of x I have q, instead of n I have power 1. So you can write it as 1 by c, here q square by 2. Apply the limit. Upper limit is q, lower limit is 0. So finally you can get 1 by 2 q squared by c. This is your W. You know that this work done is stored as electrostatic potential energy in the capacitor. So W is equal to UC, that is equal to half Q square by C. You know the relation, Q is equal to, what is Q? Q is equal to CV. Substitute this value in the above equation. So W is equal to UC is equal to half C square V square divided by C. Cancel this. Finally you can get half C V square equal to UC. this energy stored in the capacitor is directly proportional to the capacitance of the capacitor and square of the voltage between the plates of the capacitor. Voltage means nothing but potential difference. Now I have a question. Where is this energy stored in the capacitor? For this we have to find energy density. Energy density UE, which is nothing but energy stored in the capacitor by volume. Here UC you know, that is half CV square. Substitute the value half CV square divided by volume. Here volume is nothing but the space between the plates of the capacitor, which is nothing but AD. What is this A? A is nothing but area and D is the distance between the two plates. So substitute AD here. So UE is equal to CV square divided by AD. We know that the capacitance of the parallel plate capacitor is epsilon naught A by D, and the potential difference between the plates of the capacitor V is equal to ED. Say this is my equation 3. Substitute the above values in equation 3. What is your equation? UE is equal to half. Instead of C you substitute epsilon naught A divided by D. Instead of V you substitute ED. Here V squared, right? So you can write ED the whole square divided by AD. So cancel this A. Here I have D, here I have D. So D square, cancel this. So finally you can get half epsilon naught E square. So therefore UE is equal to half epsilon naught E square. Here this energy is directly proportional to square of the electric field. So what is your conclusion? The energy is stored in the electric field existing between the plates of the capacitor. So what is your final conclusion? Here the energy depends on the electric field independent of size of the plates of the capacitor. This equation is valid for the electric field due to any type of charge configuration. So far we discussed about energy stored in the capacitor, which is nothing but UE is equal to half epsilon naught E square. So what is your conclusion? Here the energy is stored in the electric field existing between the plates of the capacitor, and this energy depends on the electric field independent of size of the plates of the capacitor. I hope this video is useful to you. If you like my video, please share and subscribe my video. Thank you.